Now that you already know the idea of a direct proportion, so we are going to investigate the idea of inverse proportion, or what we call indirect proportion. So they refer to the same thing. So this example is a very simple idea of inverse proportion. So it's a very primary school question. So if you read about it, 10 men built a house in 30 days. And if, let's say, you're going to have 20 men instead, so how many days will you take to build the same house? So if I plainly use a primary school idea, it will be something like this. So 10 men, okay, needs 30 days. So now when I have 20 men, it is something like I double up my manpower. So if I double up my manpower, and because the house stay the same, the work for the house doesn't change. That means if it's a renovation or if it's a building of the house, it is the same amount of work. So the same amount of work doesn't change. So if I double up the number of men, so with the same amount of work, then I shouldn't take twice as many days. So I shouldn't take twice as many days. If I got double the manpower, I should need half the usual amount of days. So it will be 15 days. So to answer this question, okay, they will just need 15 days. So if we think about it in this way, so this is what we'll call inverse proportion. That means, right, you increase the number of men. Okay, maybe I write it here. You increase the number of men, the number of days decreases. So similarly, I can do the same thing. What if, right, I have my original 10 worker, and what if the original 10 worker, half of them fall sick? So my manpower is reduced by half. So if my manpower is reduced by half, then with the same amount of work done, the same amount of work, the work for the house doesn't change. I should take double the amount of 30 days, because now I only got 5 people working on the same amount of work. So if my number of men decrease, okay, I will take more days. So the men and the days are the inverse proportion. So it's characterized by one increase and one decrease, or one decrease and one increase. So in a way, right, there is an algebra setup. So there is an algebra setup for the two variables. So you might want to think of the house as a constant. So the house is the work done for the house is like a constant. So how many men multiplied by the number of days they work is equivalent to the house done. So you can think of it in this way. So the house is the constant amount of work. So the amount of work needs to be done doesn't change. So the amount of work that needs to be done doesn't change, but the number of men will change, and the number of days will change accordingly. So in a way, right, you can see it as two variables. The two variable will be the star and the moon variable, and is equal to the constant. So the multiplication of the two variable will be a constant. So it is a bit different from the direct relationship. So just before we go on to the setup, okay, in real life context, right, maybe I give you another example where all of you can relate to. So it's something like your pocket money. So your pocket money is constant. You got a fixed amount of pocket money. So the amount you spend versus the amount you save will be equal to the pocket money that your mom gave you. Okay, your mom gave you a fixed pocket money. So if you decide to spend more, you actually will save less. Because your mom is not going to give you extra pocket money. The pocket money is not changed. So if you decide to spend less and then to save more, then if you want to save more, then you got to spend less because you got a fixed amount of pocket money. So the fixed amount of pocket money is like the K. So the two variable here is your spending and your saving. So the two variables that are inverse, right, are related in this way. So there is something fixed, and then the multiplication of the variable will be equal to the constant. So it's something like in this situation. So if these are the two variables, so these are the two variables that is direct, you can see it as a multiplication. And if you see it as a multiplication, you also have a choice. If you would like to, if you prefer to see y as a subject, that means you prefer to see it as a formula of y, you can divide over. So when you divide over, you can see it this way. So this is the setup for inverse proportion. So similarly, if let's say my variable changes, so this will be the star, and then this will be the moon. Okay, it doesn't matter which one is the star and which one is the moon. So for example, this is the moon, and then this is the star. So they are inverse direction. They are inverse proportion. That means, right, I multiply them, it will be equal to the constant. So same here. If I multiply them, that will be equal to the constant. But if you prefer to look at y as a formula, then feel free to divide the x squared over. So you actually got two choices. Okay, so we can change a variable around. So we change a variable around. As long as they are inverse direction, the multiplication will be equal to a constant. So you can manipulate them. And you got A equal to K over B. So when the two variables are in inverse proportion, you can see as a product equal to a constant. So the constant is like your fixed pocket money, or it's like the fixed renovation to be done on a house. So when the two variables are inverse, you see them as a product, and that will be equal to a constant. Otherwise, you can divide over and you see as a y squared equal to something. So it is your choice. So you might want to see it as a product equal to a constant. The constant is like your pocket money or the house that's being renovated. So there are two variables. So one variable will increase and one variable will decrease, or the other way around. So this is an idea of inverse proportion. It's very different from the direct proportion. Direct proportion is both increase or both decrease. So see which one you prefer, whichever setup.